Well, hello everybody. New day, new video. I guess it was yesterday or maybe Tuesday. I made a video about average rates of change, and that will bring us into a new topic of instantaneous rates of change. Okay, so we need to learn about both of them, average and instantaneous rates of change, and do a little bit of comparing between them and see how they're similar and see how they're different. Okay. Anyway, well, let's start. It's a new day, so I thought I would have a cat of the day today. So why not? Let's see. Cat of the day today is Maud. She's been cat of the day before, but she has been a little bit nicer to Salem. So Salem, I think he was cat of the day last time. They've never really gotten along very well, but she's being a little bit nicer, and I think she's the instigator all the time, but she's getting there. She's been a little bit nicer, and I think they're getting along a little better. So hopefully they continue in that direction. But she's definitely a cute cat. She's the oldest cat that we have. She is 6 years old now, and we got her when she was a tiny kitten. Anyway, let's talk about math. So the average rate of change, well, I needed to include it because we are going to do some comparing and some additional problems. But yes, we have seen this, the average rate of change of some function f of x from some number a to some other number b. So the wording might be a little bit different in different situations or different problems. But you'll have a function and you'll have two numbers. All right. And this number b, we'll see, will be bigger than that number a. All right. Now, so much we've seen, right? That was the last video. This is how you calculate the average rate of change. Now, we'll learn about something that seems new and where the math is a little bit harder sometimes, and that's the instantaneous rate of change. Now, I have to be careful with how much depth I include in any one video. There are lots of things about this to talk about. The understanding of what an instantaneous rate of change is pretty deep. It's not very easy to understand, and I'm not going to address all of it in this video. In this video, I want to tell you what the very basics of it are, and show you how to go about solving a problem where you need to find the instantaneous rate of change. But I'll talk about just a little bit about the deeper meaning of it, okay? All right. And you might even begin thinking about why it might be called instantaneous rate of change. Well, the root of that word is instant. What's an instant? Like a single moment, as opposed to interval of time, such as 5 minutes. 2 o'clock today, that's an instant. From 2 to 2:30 is not an instant, right? Okay, so an instant is a singular moment of time. But anyway, so that is a little bit of another story, and I told you I'm not going to go too deep in this video. Now, it sort of looks like the average rate of change, and then there's a very clear connection between the two of them. But here's what you do. The instantaneous rate of change of a function, so you have a function at a particular number. So you have a function and a number. That's what you're given. That's the basic ingredients you need to find an instantaneous rate of change, okay? So the instantaneous rate of change of some function f of x at some number x is equal to a is the limit as h approaches 0 of f of a plus h minus f of a over h. It's really the same thing as the average rate of change if it weren't for this limit, okay? And we'll find what this limit does is push these numbers b and a right up against each other. The truth is, that's the only difference between the average and the instantaneous rate of change. That they are the same thing, but this limit pushes these numbers b and a right up against each other, okay? So they're similar. Because this one involves a limit, that might make it a little bit harder to calculate sometimes. if you've taken some calculus before, you might also know that this is called the derivative. Okay. Now, there are some examples that economists use all the time. All right. One of them is this. If you have some function or formula that calculates the revenue from producing and selling X units of some product, the marginal revenue is this instantaneous rate of change. Okay, so that's what marginal revenue is as far as how it's calculated. Also, in the realm of economics, if you have some function C that calculates or measures the cost of producing and selling X units of some product, the instantaneous rate of change is the marginal cost. All right, that's what marginal cost is as far as its calculation goes. All right, now, so those are two examples that we'll become familiar with in our class. Marginal revenue, marginal cost are each an instantaneous rate of change of either the revenue function or the cost function. So in this video, we'll explore the revenue function, but anything I say about it could be adapted to be about the cost function in the marginal cost. All right, so let's do an example. Suppose that we have a function that measures the revenue from producing and selling X units of some product, and it is R of X equals 4X minus 0.001 X squared. Okay, so we'll have to take that a little bit for granted. You could wonder about, well, how could you come up with such a function, and is it even realistic to have a function? And I guess, like, as far as that goes, this is normally called a model, okay? And models aren't perfect. So with our latest coronavirus drama, catastrophe, whatever, there have been lots of models and lots of predictions, and some of them have been closer to what actually happened than the others. So it's a model, it's something that we can work with, okay? All right, so with the coronavirus, there's been lots of that, lots of proposed models. There's lots of different ways you can come up with the models. Now, that's another subject, we can't worry about it. So anyway, suppose we have that. Now, that is what I had just described up there. That is some function that claims to measure the revenue from producing and selling X units of some product, okay? Now, it says for that function, first part, calculate the average rate of change from 900 to 904, okay? Now, for that, let's see. That would be like any of the other problems in the other videos, right? Okay. Same formula and everything. I don't think it's hard to do the calculations. This time I'll explain a little bit more about it. So, the formula from the other videos for this average rate of change would be the R function at 904 minus the R function at 900 over 904 minus 900. That's the average rate of change formula. The R function, if you plug 904 into this revenue function, you'll get 2,798.784. And if you plug in 900 into that revenue function up there, you'll get 2,790. Okay? And then on the bottom, 904 minus 900 is 4. So, subtracting these, you'll get 8.784 over 4. All right. Now, we can reduce that. Okay? If you divide, you'll get 4.392. Now, this has units because this function that we started with has units. Okay? And by units, I mean like each number in here is a measurement. That top number comes from the revenue function. So this is units of revenue in dollars. And this bottom number is how many units of production there are. So it's units are units produced. So the units for this number are dollars per unit. All right. Now, I want you to understand this dollars per unit feature of this. Okay? And I want you to understand like how this might interact with, say, a curve. If I said this curve right here is this revenue function, R of X. You know, this right here, if you could graph it, there's this little piece of the curve, and here's the spot where X is 900, and here's the spot where X is 904. Okay? Now, first of all, like these numbers here, this top number measures the difference in revenue between these 2 points. Okay? Because we have these points. The first one says at a production level of 900, the revenue will be 2,790. And this point over here says at a production of 904 units, we'll have a revenue of $2,798 and about 78 cents. When we subtract on top, we're finding the difference in revenues between these 2 points. When we subtract on the bottom, we're finding the difference in production. All right? And that gives the meaning of marginal revenue. It says right here that from this point to this point on the revenue curve, if we have 4 additional units produced, we'll get about $8.78 of additional revenue. It tells us how the revenue responds to increased production. All right? So that right there, 8.784 over 4 says produce 4 additional units, get about $8.78 of additional revenue. That's what the numbers mean. Okay? I think it's more important actually to know what all the numbers mean than to be really good at the math, honestly. So anyway, now when I reduce this number, then it's just it's the same thing. It's kind of like if I say my car drove 120 miles in 2 hours. Okay, maybe that's true, but that's the same thing as going 60 miles in 1 hour, right? I mean, really it is, as far as the numbers go. So even though this is what happened on the curve right here between the points that were given, that is an equivalent number, and it has units of dollars per unit. So we'd say, like, here's how we can think about it. Think of it like this. At a production level of 900 units, each additional unit will produce about $4.39 in additional revenue, because it's $4.39 of revenue per unit. All right, that's over a 1. You can think of it like that. For each additional 1 unit produced, we'll get another $4.39 or so of revenue. Okay, so now that's the interpretation of this average rate of change. This time, in part 1 right here, thinking about it as it's going to bring us into what marginal revenue is. Now, let's talk about marginal revenue. It is the instantaneous rate of change of the revenue function, and it will answer the question that seemed to be bubbling up over here. Okay, it will answer the question, how do increases in production influence revenue? Okay, maybe if we increase production, we'll increase revenue. Maybe if we increase production, maybe revenue would decrease if we get to some kind of diminishing return situation. All right, but that's the way economists like to talk about factors that influence revenue and costs and so on. Okay, so first let's do the calculation. So I have this same revenue function, and I want to calculate the marginal revenue at the point where x is 900. All right, now that is that instantaneous rate of change that I had in the first slide right here. Okay, so there it is. You'll have a function, and you want the instantaneous rate of change at some number x is equal to a. It's the limit as h goes to 0, f of x, a plus h minus f of a over h. Okay, so I have written that down for this function. R of x is 4x minus 0.001 x squared. Okay, I want to do r of 900 plus h, 900 is my number, minus r of 900 over h. And I have to calculate the limit as h goes to 0 on top of that. All right, now we'll learn other ways to do this, but this is where we start. Okay, all right. So let's see, what's r of 900 plus h? Well, I need to put 900 plus h into the revenue function. So think of it like this. Maybe so we don't get all the variables confused. Let's think of the revenue function like this. That's essentially true, right? 4 times the input x minus 0.001 times the input squared. And whether I call that input x or whether I just leave an empty spot to write down whatever I want to plug in is the same thing, right? Like if I wanted to plug in 900 into this function, I would write 900 here and 900 here. That's what I would do. By the same token, by exactly the same token, if I want to write in or input 900 plus h, I would put it in the same way. I would put it right here, and I would put it right here. That's what this is. That's what R of 900 plus h is. Now, let's look at how that turns out in the next line. Right? 4 times 900 plus h minus 0.001 times 900 plus h squared. That's what you see in the next line. In R revenue function at 900, plug 900 in there, you'll get 2,790. Now, once we get here, we just have to do a lot of simplifying. Okay? So, for example, what you're seeing in these two steps. Well, like, this one, I have to distribute the 4. I have to multiply everything in there by 4. Okay? And then for this one, I have to square that and then multiply through by 0.001. So when I do 900 plus h squared, that's 900 plus h times itself. If we use FOIL multiplication on that, 900 times 900 is 810,000. And then I'll get 900h, 900h, that's 1800h. And then I'll get h times h squared. Okay, so that's what I'm working with now. And then, like I said, I got to distribute through like this. Okay? And that'll take me to this. And then if I combine all the like terms that are there, you'll find that 3,600 minus 810 minus 2,790, those cancel. If I add 4h and negative 1.8h, I'll get 2.2h. And then the last like term is negative 0.001h squared. So I get that all over h. Now, let's see. Well, I guess we were going to do this limit right from the beginning. Okay? But what you'll find is that if I try to do this limit from the beginning, from up here, then when I plug in 0 for h, because sometimes you can do a limit by plugging in the number in question. Sometimes that does work. So if I wanted to do the limit as h goes to 0, one thing that might work is plugging the 0 in everywhere. But you'll find if you do that up here, you'll get 0 on the top, which isn't a problem by itself, but then you'll get 0 on the bottom, which is meaningless. Okay, it doesn't tell us anything. So we have to work all this out the way that I've done it in order to do the limit. I'm not saying there aren't other ways that you can do this that we'll get into at some point, but at least for now, with this being the way it is, that's the way that we have to do it. So then I get down to here. Now, still I can't plug in the 0 in order to do the limit, okay? So I have to try to reduce it a little bit further. So how I would reduce this part right here is like this. This is the way I would do it. There are other ways, but I mean, it just in math, there's almost always the case that there are other ways to do something, but this is how I would think about it. This division bar with that h underneath it means that everything up there individually gets divided by h. Okay? So negative 0.001h squared gets divided by h, and 2.2h gets divided by h, like that. Looking at it that way, I get some cancellation. It's not that this h cancels with this one, because if you thought that's the way you do it, then what happens is you're not taking into account that what it means is everything up there gets divided by h. Okay, so now individually there is some canceling. H squared over H is H. Okay, so I get negative 0.001 H plus 2.2 times H over H. Cancels, leave me just 2.2. Now, ultimately, I needed to do this limit. And maybe I tried to plug in from the beginning and it yielded 0 over 0, which I just can't work with. So then I had to do all the simplifying. And finally, I get down to this point where I can achieve that limit by just plugging in at this point. So what happens if you let H be 0? What's negative 0.001 times 0 plus 2.2? It's 2.2. Okay, so there's your marginal revenue at a production level of 900. Okay, now because the instantaneous rate of change is really the same thing as the average rate of change, it will have the same units and the same interpretation. Okay, so the average and instantaneous rate of change always have the same units and same essential interpretation. For the average rate of change, we calculated the additional revenue as the top number and the additional units produced as the bottom number. So the units were dollars per unit or dollars of revenue per unit. Okay, so that same thing will be true for the instantaneous rate of change. It will be in dollars per unit, and the interpretation will be the same. At a production level of 900, because all of this was based on that value of X is 900, so at a production level of 900, each additional unit produced will yield about $2.20 in extra revenue. Okay, all right, so there you go. That's how you calculate it. All right, that's for our class. That's what instantaneous rates of change are going to look like. That's the kind of math that is going to be involved in their calculation right here. Okay, and then we can interpret it as same way as the average rate of change. Okay, now let's see how these are the same and how they're different, because remember how I said it's the same interpretation, but we did get different numbers, right? I mean, here this one said at a production level of 900, each additional unit produced will yield about $4.39 in additional revenue. Okay, and then this marginal revenue over here, I described it in the same way, but it's the number was $2.20. Okay, so well, those aren't the same, but I'm saying they have a very similar interpretation. So let's talk about how they're the same and how they're different. So yes, the average and the instantaneous rate of change, they're similar, but they're different. Okay, so remember when we calculated that average rate of change, what we found our numbers to be was the change in revenue over the change in production. Thinking of it like that on the revenue curve, as you jump from this point on it to this point on it, this much additional production gets you this much additional revenue. We use symbols delta R and delta X to be changes. Okay, so this is the change in production. This is the change in revenue. You could think of it as the additional production to jump you over this way. You could think of this as to be the additional revenue to jump you up there. So it tells you to get from this point to this point how the production and revenue have to change. Okay, so that's what the average rate of change is. The change in the revenue over the change in production for whatever the values are given to be. Now, all right, the instantaneous rate of change is really the same thing, right? I mean, I said that much. It's just that there's this limit, okay? And what that limit does is take that initial given point and then have another point that is somewhere a little bit further down. Okay, and if the limit goes to 0, this point 900 plus H gets pushed over to the other one. Okay, so it measures the same thing, all right, but with the change of production being extremely small, because the H is going to 0, That's pushing this point horizontally over to that one. Okay? All right, now that's why we might get different numbers. You would find, though, that if these points were closer together to begin with, then the number you got for the average rate of change would be very close to, approximately equal to the instantaneous rate of change. Okay? All right, but they measure the same thing. It's just that on the instantaneous rate of change, the change in production will be extremely small. Now, that's generally how economists like to do things. They'll use the instantaneous rate of change on their functions rather than the average, but I won't say that it's always the case that one is used above the other. Well, we need to know both of them. Okay, now I know that is pretty deep. This might be, in terms of its complexity, the most difficult video I've made yet, in terms of how much there is to understand. Okay, so it is something that you will have to think about. There are lots of different levels to it. One level is to make sure that you could do the math. Now, there is a problem just like this on the assignments. The numbers are a little bit different in the function, but just how about this? I mean, here's your outline for how to go right here to do the calculation. And then if you can get that right or practice, fix your mistakes until you can get it right, then that's one thing accomplished. The other thing to accomplish is all these other notes about what the numbers mean. How do you interpret the number you get when you calculate the marginal revenue or the instantaneous rate of change versus the average rate of change? Now, that's all here in the notes on the video. It's all been included, but there are some dots that you have to connect, okay? So now that will take a little more thinking, but that's like if you want to learn the level of mathematics that most economists use to explain their reasoning, then this is it. This will be a really important step. So do the math, ponder the concepts, and if you're having any trouble, if it's just not sticking, I want to hear from you. But I'll be putting out another video real soon with some additional examples and to take this a little bit further.